Welcome to the class Data Warehousing and Data Mining, BSA 720. My name is Nilofer Versgani, and I will be your instructor for this online class this semester. I'm really happy to be teaching you guys this course. I'm a new faculty member at LaSalle University, and I've been here for 2 semesters now. And I've taught this course before as well, so I'm happy to have you guys in my class. Just an introduction to this class, we are going to be covering some basic concepts in both data warehousing and data mining, but because this is a course being offered in the business school, the bulk of the content that we are going to cover this semester is going to be around the concepts of data mining and all the models that you can apply to extract useful information out of data. Data warehousing segment of the course is going to be restricted to a more business intelligence focused overview of how data warehousing works. So we're not going to go into the IT and computer science portion of data warehousing. Rather, we're going to focus on the business intelligence and how we can use data warehousing to get the data that we can run the models for data mining then. So you guys must be aware as a part of your business degrees that depending on any industry that you have worked in or you are going to work in which involves business, there are applications such as order processing, general ledger, inventory, human resources, payroll, billing, checking accounts, information claims, or customer data, customer acquisition. All of that constitutes as data. All these applications are important systems that run businesses. They process orders, they maintain inventory, keep accounting books, service the clients, receive payments, process claims. Without these computer systems, no modern business can survive. Companies started building and using their own systems in the 60s and have been completely dependent on them ever since. So as an introduction to the class, today we're going to focus mostly on the data warehousing portion of this course, and slowly and gradually we're going to make our way into data mining. So the first 2 weeks we're going to focus mostly on data warehousing, and the assignments and all the reading material would also be focused on data warehousing. As a part of this course, we're going to be using a couple of softwares. So the first one that we're going to be using is called R. And we're using an accompanying environment software with R called RStudio to run R. I have uploaded another video that you can watch in order to download and install both R and RStudio on your computers. We would need both the software to work. Both the software are free, so you don't need any licensing information or code to download it. You can just Google it and follow the steps that I've provided under Module 1. As an introduction to today's lecture, we're going to focus on data warehousing. First, we're going to talk about why data warehousing is important and what has it evolved to. And then we're going to go over some basic building blocks of data warehousing, some definitions and jargon that we're going to be using throughout the course. As mentioned in the syllabus, we will be using 2 types of books, or rather 3 actually. The first one is labeled as textbook 1 throughout the content of the course, and this is titled Data Warehousing Fundamentals. The second edition, the author is Paul Raj Punia, and I would recommend buying this book and going through the chapters if you do not have any experience before with data warehousing and decision support systems. Chapter 1 and 2, which we are covering today, would focus mainly on the need for strategic information and data warehousing, and what are the basic definitions used in data warehousing. Some of the slides on this deck also have content from this recommended text called Data Mining Concepts and Techniques. This is not a compulsory read, but if you want some more clarification on the slides that are not from textbook 1, you can use this book, and these are from chapter 2. So let's start on with the first lecture. In today's world, as businesses have grown more complex and corporations have spread globally, the competition has become fierce, and business executives have become desperate for information to stay competitive and to improve the bottom line, which is why data warehousing came into existence. It's a new paradigm specifically intended to provide vital strategic information. The organizations earlier had began to achieve competitive advantage by building data warehouse systems, and now we can see that businesses that do have access to data, such as Apple, Google, Facebook, Netflix, are the ones that are growing and are the future of where most of the companies are headed. Organizations achieve competitive advantage through retail, customer loyalty, marketing planning, in finance through risk management and fraud detection, in airlines through profitability and yield management, in manufacturing through logistics and cost reduction, in utilities through asset management and resource management, and in government industries through cost control and manpower planning. All of these constitute as strategic information for the specific industry that they operate in. There are various ways of organizing and managing information for decision-making use, and we're going to cover them in today's lecture, and we're also going to briefly explain what is data warehousing and why it ended up being a viable solution to getting this strategic information. The word data comes from the word datum, which just means fact. Your name is a fact, your phone number is a fact, your address is a fact. The distinction between data and information is that information is data that is presented in a meaningful, understandable, and beneficial format. Information is data that has been organized, sequenced, correlated, summarized. For example, a phone book or a table or a summary that you use or a report. The need for information to formulate business strategies, establish goals, and set objectives has grown over the years as we have more and more access to data nowadays. Some examples of business objectives include retain the present customer base, increase customer base by, let's say, 10% over the next 5 years, improve product and quality levels in the top 5 product groups, or gain market share by 10%, or increase sales by 15%. For making these decisions, executives and managers need information, and for that following purpose, they need an in-depth knowledge of the company's operations. They need to review and monitor key performance indicators and note how these affect one another and how business factors change over time. So once we understand all of that about our data converts into information which can be then used for decision making. Let's look over some basic definitions. A database is a place where you put your data that you wish to convert into information at some future time. And a database management system, normally referred to as DBMS, is a software that converts the data into your database into information. It's the DBMS that provides you the capability of cross-referencing, correlating, sorting, and summarizing. An example for that is Microsoft Access. As I mentioned earlier, the data that we collect as a part of our business operations is then converted into information, and that information is used by managers and executives to create decisions. A decision which is based on information is less likely to fail, and even if it does fail, you did try your best to utilize all the information that you had in hand and use it in a systematic and logical manner to arrive to the final decision, which you can then justify. And even if it goes wrong, you do have a justifiable process to which you arrived to that decision. So this slide over here represents some of the jargon that is used typically in data warehousing. When you hear data resource management, this is a DRM system which helps you manage the different types of data that you have stored in your DBMS, the database management system. Information, as we said earlier, is data that has been processed in some way, or it has been organized in a logical fashion that makes more sense to you. For that, we use an online transaction processing system, or an MIS, management information system. An example of that could be your transactions for a grocery store, for example. If they have been tabled and summarized by, let's say, day, or they've been summarized by store, that data has been eventually converted into information that can be used for decision making. The information then constitutes as knowledge, and this knowledge is then used to form decisions. So the process is usually called knowledge management or knowledge work systems. These usually refer to the transfer of knowledge or information from one person to another. So for example, if I hire a new employee, how do I train my new employee using my old employees who are well versed in this area? DSS, or a decision support system, or an executive information system, again, they use the same information and knowledge that was gathered by the DRM and DBSM to DBMS, to come to the decision or help the decision-making process become easier. Later on, once we have used all of these resources above to create either a data warehouse or a data mart, we can then apply techniques such as data mining and OLAP to make this decision-making process more smooth and more systematic. As we all know, with the increase in technology, the amount of data that businesses can have access to and eventually store and use has grown tremendously. This has resulted in growing amounts of data in operational databases, and this data can then be converted into information and knowledge to eventually help us in the decision-making process. Organizations now focus on ways to use this operational data to support decision-making in order to get competitive advantage. However, operational systems were never designed to support such business activities. Businesses typically have numerous operational systems with overlapping and sometimes contradictory definitions, which is why there was a need for data warehousing. Organizations need to turn their activities of data into sources of knowledge so that a single integrated, consolidated view of the data is presented to the user. A data warehouse was deemed the solution to meet the requirement of the systems capable of supporting decision-making and receiving data from multiple operational data sources. So the objective was to access and combine data from a variety of data stores, perform complex data analysis across these data stores, create multidimensional views of the data, and easily summarize and roll up the information across subject areas and business dimensions. So, for example, think of a retail chain of stores. Let's say it's a grocery store, and they have multiple stores across the country, and they store sales or transaction data in each store. Now, it could be possible that each of these stores use a different type of system to maintain the sales for the data. One of them might be using Excel, the other might be using a different software to record these sales. So our data warehouse should be able to access and combine data from these variety of data stores and bring them together into one database. Perform complex data analysis across the stores. So for example, if I want to summarize by store, or if I want to summarize the sales by product, or summarize the sales by geographic regions, I should be able to do that. Create multidimensional views of the data. This could include both table views or just views using charts or graphical views. We're going to cover most of that under the section for data mining. And our database or our data warehouse should also be able to summarize and roll up information across subject areas and business dimensions. So for example, I should be able to compare my sales in the Northeast stores to my sales in the Western region, so that I can decide which region is more profitable for me and where do I have more capacity to expand. In order to meet the objectives that we identified in the earlier slides, there are a number of problems that we usually face. The first one is data is scattered across incompatible structures that we probably cannot bring together, or there's lack of documentation preventing the integration of older systems into newer systems, or internet software like search engines need to be improved, or accurate, accessible, huge amounts of data called metadata across multiple organizations is hard to get. The answer to that was creating a system environment or a data warehouse that is designed for analytical tasks, that is designed for multiple applications, that is easy to use and has direct interaction with the system users without the assistance of IT personnel, that is updated periodically and includes current and historical data, and the users have the ability to run queries and get results online, and the ability to initiate reports, and the solution is what we call a data warehouse. The characteristics of a data warehouse include that it's loaded from multiple operational databases for the purpose of end user access and decision support. So if the manager is the end user, then he needs this data or the different views of the data in order to make his day-to-day operational decisions. A data warehouse differs from an operational system that it contains normal static data. By static, we mean that it's true to one specific point in time, and is updated in a scheduled manner through loading procedures. Another characteristic of a data warehouse is that it's developed to accommodate random and ad hoc queries and allows users to drill down to minute levels of detail. So for example, I want to find out which store, what are the sales of the stores that are smaller than 200 square feet and located in the Northeast region with 2 or more managers managing the store. So that level of detail should be accessible. Therefore, an earlier researcher in the area of data warehousing, Bill Inman, defines a central data warehouse as having these 5 characteristics. The first one is that it's subject-oriented, which means that it revolves around these major categories. So for example, if I'm looking at the data for a bill of material, it's going to include all the material that goes into my product and how much of it goes in there, what is the cost of each of the material, and what is the final cost of making that product. Or it could be a customer profile. What are the preferences of my customer depending on what I'm trying to sell them? So it needs to have a subject around which the data is congregated. The second characteristic is that it's integrated, which means that is displayed by consistency in the measurement of variables. So for example, there's only one definition, one identifier for each subject area. If I am measuring sales, then it should be in US dollars only, and in my data warehouse it should be known that the currency of choice is US dollars, and I don't have multiple currencies, so because then I won't be able to compare sales across. The third characteristic is that it's time variant. Data in the data warehouse is historical and accurate as of some point in time. If the data value changes, then we need to update that, but keep that old data with that particular time associated with it. And because of that third property of time variance, the data in our data warehouse is static, which means that if my sales for the first month of the fiscal year were 200,000, then that refers to the first month. When the second month sales arrive, those sales are only associated to the second month, which means that it's time variant and it's static in regards to the timestamp on that data value. And finally, the fifth characteristic is that the data is summarized at different levels. So, for example, like I said, sales could be summarized by region, they could be summarized by store, they could be summarized by product type. So the granularity levels are what are determined by the data types and what data you're actually storing. But the levels help you view these multidimensional views of the data and then help make decisions. So after all of the setting the objectives and defining what it means to have a data warehouse, the benefits include that the data warehouse enables managers, workers to make better, wiser decisions which are more systematic and less biased. They also help us identify hidden business opportunities which may not be as visible as earlier. So, for example, with the amount of data that Facebook has now about our preferences, it is able to target ads to us which are very specific to our requirements. It helps us bend with the customer. We understand who our customers are and what are their needs so that we can improve our products and services according to that. And like I said earlier, precision marketing and target advertising is something that really has grown because of data warehouse and all the data that we have available. Now let's move on to the different definitions that we see across the basics of data warehousing. A common term that you're going to notice a lot is called a data object, which represents an entity within your database. So for example, if you have a sales database, an object could be a customer, or it could be store items, or it could be sales. If you have a medical database, a data object could be the patients or the treatments. A university database would include students, professors, the courses or the credits that they're taking. These are also called samples, examples, instances, data points, or tuples. Data objects are described by the attributes. So the attributes could be referred to as in the columns. So think of a database as a table where the rows represents the objects and the columns represent the attributes. So for example, if I make a table of all the students in my class, then in the rows I'm going to have the student names, which are my objects, and I could have their current GPAs, their previous work experience, their high school information, all of them under the columns section, which would form their attributes. Now, the attributes are features or dimensions that help you give or describe your data more than what the name gives, just what the name gives. So, for example, an attribute could be the name or the address or the phone number. It gives you more information about your specific data object. These attributes could either be nominal, binary, or numeric. Now, A nominal attribute is something which is just categorical. So for example, gender is a nominal attribute, male or female. Binary means it falls under two categories. The difference between nominal and binary is that binary categories are also nominal, but if you have more than 3 or 4 categories, then it's not binary anymore, it's just nominal. So for example, your marital status is a nominal attribute and not a binary attribute, whereas gender is both a binary and nominal attribute. On the other hand, a numeric or a quantitative attribute is further divided into interval scaled or ratio scaled. Let's look at that further. An interval scale is something which is measured on a scale of equal sized units. So your example is temperature or dates. There is no true 0 point on an interval scale, whereas on the other hand, a ratio scale has a 0 point. So for example, weight or length or how much your net worth is, all of that falls under the ratio scale, where 0 actually does mean something, or the absence of. Another way to classify data attributes is identifying whether they're discrete or continuous. A discrete attribute is has a countable finite or infinite set of values. So for example, if I describe the weather as rainy, cloudy, sunny, or snowing, then these are 4 types of outcomes that the type of weather can have. Whereas if I'm measuring the amount of precipitation, which is also technically finding out what the weather is going to be like, is a continuous attribute, because measuring the amount of precipitation gives us a quantitative value which falls on the continuous scale. It has real numbers and can be measured and represented using digits. So continuous attributes are typically presented as floating point variables. So for today's lecture, we're going to stop here, and we're going to continue with the remaining building blocks and concepts of data warehousing in the next class. But please go over the assignments and the remaining material that has been posted under Module 1, so that you have all the information that you need for this week's deliverables.